Hi, welcome to Learning Monkey. I am Vikram. In this class, we'll try to understand variables and memory. So the concept of variables, the definition of variables, and how the variables will get stored on the memory has already been discussed in our previous video. If you haven't watched that video, please watch that video and come back here. And every video in our channel is going to be a part of entire course or a playlist. Our suggestion is to follow the entire course so that you can have better understanding of the concepts. In our previous class where we have discussed about the definition of variables, there we have said that so we had a visualization of variables and memory. So there we have said that how the data will get stored, how the values that are stored, the values that are assigned to the variables will get stored on the memory. So this is the visualization that we had in our previous video, and these are the memory addresses, the addresses of each and every block. Whenever a variable, for example, take variable a is equal to 10, means the value 10 will get assigned to a, which means for example, if a is assigned to the memory location 4 and this 10 will get stored onto the memory. So is it the way the things will get stored onto the memory? No, not exactly. So how the things will get, how the values of the variables will get stored onto the memory, so that we will try to understand in this class. So this is not the way. Why? Because the computer does not understand the decimal numbers. For example, if you want to store 14, the decimal number 14, the symbol 1 and 4. So in our primary school where we have learnt about decimal numbers, there we have seen that the decimal numbers are made up of 10 different symbols. The different symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you take any decimal number, they are going to use only these symbols. So these symbols 1, 4, 5, 6, so 15, 16, these symbols, the computer cannot understand those symbols. So what are the symbols that the computer can understand? It is the computer understand binary number system. So this entire concept of number system is out of the scope of this course. So just to give an introduction, we are discussing these concepts in this class. So no need to understand the number system and all those concepts. The concepts of number systems will be clearly explained in digital logic design, so which is already there in our playlist. So no need to go there and no need to understand the number systems. Just try to remember some points and try to understand some logics that we are going to explain in this class. So that understanding is more than sufficient for this course. So about these concepts. So the decimal numbers are not understandable to the computer. The symbols that are understandable to the computer are binary symbols, two symbols, they are 0 and 1. So the number system that is used by a computer is what we call it as binary number system. So in the binary number system we have binary itself states that 2. So the binary number system itself has two symbols, one is 0 and other one is 1. So whatever the decimal number, it may be 14, 15, 16, that number will get converted into a binary representation. So even though we write the programs by using a is equal to 15, a is equal to 16, that 16 will get converted into binary. How that conversion is done? How that conversion is done, it is not required at this point of time. So just try to understand some points and try to remember some points. So here is the binary representation of decimal numbers. So this is the binary representation of these decimal numbers. The decimal number 0 can be will be represented by a 0, and the decimal number 1 by 1, 2 is 1 0, 3 is 1 1. So this way a decimal number can be represented in binary. So the point that we have to understand is, so the point that we have to remember is every decimal number can be uniquely represented by using by using some combinations of binary symbols. By using zeros and ones, we can represent every decimal number. That point you have to remember. But what is the point that you have to understand is, for example, if we have one bit, if we have only one bit, how many numbers can be represented? We can represent either 0 or 1. So if you have only one bit, we can represent either 0 or we can represent either 1. So with one bit we can represent two decimal numbers. It is 0 or 1. So, and another point that you have to remember is, so for a given binary number, for example, if this is the for a given binary number, this is the binary number 11 is representing decimal number 3. So this 11 to this 11, if you add as many number of leading zeros to the right side, to the right hand side of the given binary number, if you add as many zeros as possible, so the value does not change. To the right of the binary number, this is binary number 11. 11 is represented as the decimal representation of 11 is 3. So to this 3, if you add as many zeros to the right, the value does not change. This value, this point that you have to remember. For example, if you take a decimal number 69, to this you add as many zeros to the right, the value does not change. It is going to be 69. To the left, if you try to add, the value will change, right? Okay, so that logic applies here also. So with one binary, with one bit means one binary symbol, with one binary bit, this is what we call it as bit. If you have one bit, we can represent two decimal numbers. If we have two bits, with two bits, how many numbers can be represented? See here, this 1 can also be represented as 0 1. So this 0 0 can also be represented as 0 0. With 2 bits, how many numbers can be represented? See here, 4 decimal numbers can be represented. With 2 bits, if we have 2 bits, we can represent 4 decimal numbers. Okay, with 3 bits means to this we can add extra 0, the value does not change. To this also we can add an extra 0, and with 3 bits, this is 3 bits. See here, we can represent 8 decimal numbers can be represented by using 3 bits. Okay, it is from 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. 8 decimal numbers can be represented. The number of decimal numbers that can be represented by using the number of by using n number of bits, it is 2 power n. So let's try to understand this point again. For example, if we have 4 bits, the number of numbers that can be decimal numbers that can be represented is here n is equal to 4. If we have the n value as 4, n is equal to 4, the number of numbers, decimal numbers that can be represented with 4 bits is 2 power n. It is 2 power n. And what is the range of those numbers? The range of those numbers is from 0 to 2 power n minus 1. So what is 2 power n? Here the value of n is 4. With 4 bits, 2 power n means 2 power 4. 2 2's 4, 4 2's 8, 8 2's 16. 16 decimal numbers can be represented. And what is the range of those numbers? It is going to be from 0 to 2 power n. 2 power n is 16 minus 1, which means it is 0 to 15. So let's check this. With 4 numbers, with 4 bits, how many decimal numbers can be represented? It is from 0 to 15. If you take 16, in order to represent 16, we need 5 bits. So try to understand that logic. As the value of the decimal number increases, the number of bits used to represent in binary will increase. Okay. So that is very important to understand. For example, if you have 6 bits, If we have 6 bits, how many numbers, how many decimal numbers can be represented? 2 power 6, 16 to 32, 32, 64 numbers can be represented. And what is the range of those numbers? With 6 bits, what are the numbers that can be represented? This logic is very, very, very important to understand. Please try to understand this logic until you get the clarity. Okay, what is the range of those numbers which can be represented by using 6 bits? It is from 0 to 63. Okay, so above 63 if you want to represent, it is not possible because it needs 7 bits. Okay, so this is how the number system, the binary number system will be. It is just a brief introduction. No need to understand beyond this because this is out of the scope of this course. Now coming to our concept of representation of these variables, storing those variables onto the memory. How these variables will get stored on the memory? So as we have seen that the values will get stored on the memory in this way in our previous video. This is not the way. So what happens is, every block is made up of 8 bits. See here, 8 dashes are there. Each dash is going to represent 8 bits. So every value that we would like to store on the memory block is represented in 8 bits. So 8 bits is what we call it as 1 byte. So this is the general computer terminology that you have to understand. 1 byte is equal to 8 bits. So if the representation is done by using 8 bits, then it is also called as 1 byte. So a block of memory is going to store 8 bits, means 1 byte. By using 8 bits, we are going to represent the numbers. So it may be 1 byte, it may be 2 bytes. In our memory, we are going to take 1 byte. So what does that mean is, for example, if we want to store 14 onto this memory, how that value will be on the memory? So for example, A is a variable and it has been allocated with memory location 3. In this memory location, I want to store 14. So what is the decimal value of 14? The binary value of 14. The binary value of 14 is 0, 1, 1, 1. What about the remaining leading bits? The remaining leading bits are stored with zeros. Okay, so this is how the 14 will get stored onto the computer. For example, in the computer, in the program, if you have given A is equal to 14, what the compiler will do is, this 14 will get converted into this number. As we are using 8 bits, 1 byte of memory is allocated for each decimal number. So these 8 bytes, so these 8 bits are represented in this way. So 14 can be represented by using 8 bits in this way. Now this is the value that will get stored in this memory location to represent 14. Whenever we want to access that 14, we go to this memory location, we get these bits and we are going to convert it into decimal number, and that decimal number will be shown on the screen. So this is how the computer works. This is how the variables, this is how the characters are also stored in this way. Special characters like hash, @ all those symbols, everything is in the form of binary. Just remember that. Everything is going to have a special codes are used to represent the things. In the later coming videos, we will try to understand that concept also. So in this video, the point that you have to remember is, everything is represented in binary numbers. Binary numbers means zeros and ones, and the other point that you have to understand is, if we have n number of bits, the number of decimal numbers that can be represented is 2 power n, and the range of those numbers is from 0 to 2 power n minus 1. So that point you have to understand. If you didn't get this point, so if you in one watch. If you are not able to understand this point, please watch this video as many times as possible until you get this clarity. So this point is very important to understand. Please try to understand this point. Hope you got the clarity on this concept. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. And if you have any doubts regarding this concept, please post your doubt in the comment section below. And if you feel that this video is helpful to you, please give us a like symbol and please share this video with your friends so that they will also get benefited. Thanks for watching.